Thank you. So good evening from Mumbai, and thank you very much for organizers for giving me an opportunity to talk about our balloon activities. So basically, this talk is about opportunities for scientists for exploring space science using balloon as a suborbital platforms. Of course, this is our main activity, but we have also have a lot of international collaborations where we use balloons before any satellite experiment for not only for astronomy, but of course in other branches of science also. So this is the brief outline of my talk. So I will give you a brief overview of scientific ballooning in India, and then I will talk about dedicated facilities which is set up for balloon experiments in India, in the central parts of India. And then I will talk about briefly use of scientific balloons, not only for astronomy, but like in atmospheric science, as well as other new avenues which has been now discovered using balloons. And then I will summarize my talk by these future directions. So history of ballooning in India is quite old. Actually, it started in late 1940s when scientific ballooning activity was initiated by Dr. Homi J. Bhabha, who was the founding director of Tata Institute of Fundamental Research, from where I am right now. And at that time, they were basically studying the secondary cosmic rays radiations using cluster of rubber balloons, which were flown up to 25 to 30 kilometers altitude from the Earth. And then several scientific balloons were launched during 1940s and 1960s, basically to study the secondary cosmic rays radiation. Then it was realized in late 60s that we should have a dedicated facilities in India where everything is under one roof, like balloon production, launch, data collection, and recovery of the payload. So considering this mind, facilities was basically set up in the center part of India called Hyderabad. The reason for setting these facilities in this part of India was because it's close to the geomagnetic equator, like 19 degree above the geomagnetic equator, so that you can actually reduce the contamination of charged background particles, because experiments at that time were mainly on cosmic rays and X-rays. And then later on, these facilities become quite big facilities where main zero pressure balloons are launched in two seasons, like we call it summer, February to April, and winter, October to December. And of course, now we have a balloon flights during monsoon season also to study the monsoon pattern in the Asian regions. And the main experiments are done in astronomy, like X-ray and far infrared. And also we have experiment in astrobiology and atmospheric science. Apart from that, also we do a lot of research and development in balloon engineering, so that we develop new technologies in ballooning. So this is the facilities called in Hyderabad, central part of India, close to geomagnetic equator, where we have everything under one roof. We have a control room for tracking the balloon and payload. We have launch field. We have balloon fabrication unit. I will come to that later on. And so we basically provide balloon design and fabrications to the experimentals. We design balloons. Then we have control instrumentation, where we basically provide electronics packages or controlling instrumentation to the experimentalists. And then also we have workshop where we design payloads, gondolas for experimentalists if required. And then also we have atmospheric science activities. We have various labs with different kind of atmospheric science facilities. So the goal of TIFR balloon facility is basically to provide opportunities for research, development, and evaluation of science payload, particularly using stratospheric and mesospheric balloons. And these facilities is not only dedicated to national laboratories, scientists from national laboratories, but also people from abroad are using these facilities, like Japan, USA, and Singapore and France. They have recently used these facilities. And also, as I said, we also do a lot of R&D activities to keep our advancement in ballooning. So the type of plastic balloons which we develop has different kinds, like main balloons are called zero pressure balloons. We also develop high altitude balloons for mesospheric studies. Then we have wind sounding balloons, tethered balloons, and sounding balloons. So in zero pressure balloons, basically used for astronomy experiment, which can carry payload up to 2.5 ton, 2500 kg. They can go up to 32 to 43 kilometer, and high altitude balloon now can go up to 51 kilometer, but only with 10 kg payload, because these balloons are used ultra thin polythene. So zero pressure balloon, which we have actually designed, the largest balloon has volume of 740,000 cubic meter. The suspended balloon, it can carry is 800 kgs. And basically our float and altitude is like 43 kilometer for X-ray experiment and 32 kilometer for infrared experiments. And the float duration is roughly like 8 hours. Of course, total duration of the flight is 10 to 10 hours, but we can get 8 duration float using the zero pressure balloon. And this float duration actually is defined by the corridor where we can actually fly our balloons. Like Hyderabad is in the central part of India, and then we have a 500 kilometer across the boundary, which is defined by ATC, air traffic control regulations. So within that boundary, we actually fly our balloon. That's why this duration is restricted to 8 to 10 hours. And then high altitude balloons actually used for mesospheric studies, because they go up beyond 50 kilometer, and beyond 50 kilometer is the mesosphere. And actually we have a world record of going up to beyond 50 kilometer, but these balloons basically using very ultra thin balloon like 3.8 micron, whereas zero pressure balloon we are using 12 to 25 micron uh, cell thickness of polythene. So since these are very ultra thin balloons, so they have a total cell weight is less. That's why they can go up to 51 kilometer height. Then we also have a lot of sound ballooning experiment. These are called wind sounding, because they are used generally as a pilot balloons before any satellite launch or rocket launch, because with these balloons we can actually check the conditions of wind, like temperature, humidity, wind speed. And also these types of balloons are used for by atmospheric scientists for ozone studies and other atmospheric science studies. Then we also developed tethered balloons. So these tethered balloons are very good balloons to study the in situ measurements. For example, you see example here where this balloon is used in a ship somewhere in the Bay of Bengal. So basically they can go up to 1 kilometer with suspended payload of 1 kg to 3 kgs. So they are very good to study the boundary layer studies, or you can actually test your flight packages and so on. And then we also developed special balloons. These are called oblate kind of balloons, and these are actually used by our space agencies for zero gravity tests. Like one example is here, where these balloons are used for rover, which was used in Chandrayaan-2 to simulate the movement of rover in the clean room in space agency's laboratory. Similarly, other balloons are used how we develop the antenna in geostationary satellite and so on. So they are very good to basically simulate zero gravity test in the lab. And apart from the ballooning production, we also have our tracking system, where we use S-band tracking system, which will basically operate at 2 gigahertz frequencies. So where we have both uplink and downlink commands. So uplink is basically to command the payload and balloon and see the trajectory of these balloon and payload, whereas downlink we can actually have a telemetry where we can get the data, online data and health parameters of the payload. So I will now quickly go through some research areas where these balloons are used. So of course, our main experiments are on space astronomy, in particular in far infrared astronomy and X-ray astronomy. Apart from that, we also have a lot of atmospheric science experiment, particularly from scientists from outside India, like NASA or USA or even France. And also now these balloons are regularly used for commercial balloon flights. Like one of the things which is coming up now very intensely is about the space tourism, where these balloons can be used for space tourism, for carrying the people and bringing them back to the Earth. And another very interesting thing which is coming, particularly in India, where these balloons are used for communication purposes, particularly when we have a natural disaster because of flood or other thing, where you can use these wireless devices using these balloons. So I will just give some glimpse of our far infrared astronomy in TIFR using balloons. So basically, we have a 100 centimeter far infrared telescope where we have 100 centimeter primary mirror, and this telescope is basically used to observe one interesting line, C2 line, ionized carbon line, and 158 micron using Fabry spectrometer to probe the photo-dissociated region in star-forming region. And so basically the total mass of this payload is 850 kgs, and this telescope has been used 26 times since 1983 with different kinds of instruments. And with this kind of telescope and like a Fabry spectrometer at 158 micron, we can actually get the C2 line mapping with a resolution of roughly 1 arc minute. And this is the example where we have actually mapped several star-forming regions in our Milky Way galaxies. Where the advantage of this ballooning experiment is that we can actually observe large areas of star-forming region in C2 line, which is real not possible with the satellite experiment. Of course, you get better resolution using satellite experiment. So this has been used very regularly. And this is just to give you example, the volume of this experiment. So for example, this is the far infrared experiment, and this is the main balloon. So total length of this total load line is like 200 meters. So it's really a big experiment which is regularly used from Hyderabad. And apart from astronomy, now we have a lot of atmospheric science experiment, particularly of national importance. For example, this example is balloon campaign to study Asian tropopause aerosol layer called BATAL, which is a collaboration between an Indian Space Agencies and NASA and University of Wyoming and Cannes, France, where they are basically studying the aerosol optical properties and size distribution during the monsoon in India and East Asian regions to study the monsoon pattern. So this is a regular feature now where many balloon flights are done during monsoon period from India to study the monsoon dynamics in Asian regions. And apart from that, we also do this experiment to study the, for example, this is the example of black carbon aerosol studies. This is the main met aerosols which affect the monsoon pattern again in India, and to study these kind of black carbons within India or neighboring countries, balloon experiments are done. And this is another example where balloons are used for studying the tropospheric and stratospheric ozones to particularly study the ozone concentration and greenhouse effect, which actually affects this kind of studies using balloon can be used. And apart from that, now balloons are also used for the commercial flight. So this is one example where this our zero pressure balloon was used by one of the Google executive called Alan Hustas to jump from the space. So it is called human space jump, which was done in 2014. And this is the world record, which has been established by using this dual balloon volume of 328,000 cubic meter, where this Alan Hustas jumped from 41.422 kilometers, which is the still the world record for space jump. So these kind of crazy things are also done using balloons. But what is important is this experiment called live animal experiment, and this experiment was done by engineers from Singapore. Idea was to basically to send first Singaporean into space using balloons, and so before basically to test the space capsule in which these people were supposed to be sent. And so before testing their capsule with the man, they wanted to test with the live animals. So where these kind of live rats were sent using balloons from Hyderabad, where they actually tested their space capsule, and this space capsule was later on used in Australia, where they were trying to send a man in this capsule. So far, this was the first attempt from India to send live animals into stratospheric altitudes from our balloon facility. And then now these balloons are, particularly the tethered balloons, are used for wireless communication. So this has become very important in India, particularly where we have a lot of natural disaster, earthquakes, floods, or landslides, and they are used as a last mile when we don't have electricity and power. So these balloons can use with a Wi-Fi communication, and they can be located at different places. So this has been taken now by Government of India as a national importance program. So the future plans from balloon facility, of course, astronomy is our main mandate, and we will continue with the advancement of detector, like we are continuing with Fabry-Pérot spectrometer, but with higher resolutions, where we can study the dynamics and kinematics of the star forming region using C2 lines. And we also have a plan to develop very high altitude balloon to go up to 54 kilometers, so that it gives opportunities to atmospheric scientists to study the mesosphere with their experiments. And also now we are developing a super pressure balloons for long duration flights. So this is the plan of our space agencies, where we can fly our balloon from like Andaman and Nicobar Island, and we can have a recovery in the land in India. And also we are developing zero pressure balloons for heaviest payload like 6.5 ton. So the details about balloon facilities can be got in this web page, and this is my contact email where you can contact me. And I have a very small movie I can show, just 1 minute movie, where this is just to show how this IR experiment is done. Okay, thank you very much for your attention.
Thank you, Devendra. A nice and very interesting talk. I have, from a theoretical point of view, because I don't know nothing about this, how is the financial cost of this program? Is it too expensive?
Not very expensive. So since we are fabricating our own balloons, so cost, labor cost and other is quite low in India. So these are not very costly. So main costly item is of course our instrument. Like in case of I do IR astronomy experiments, so that Fabry-Pérot spectrometer is really costly. So then we have so balloons are not very costly, and operations of the balloons are also not very costly. But what important is that we have a very good recovery system of balloons after the completion of the flight. We have very many sensors where we track these balloons and recover our payload very safely. So we have 100% success rate there. That's why we are, as I gave example, that we have flown our own experiment 26 times. This is just because our recovery operations are very highly successful. So that is.
Okay, and imagine, well, you recover the instrument, and the balloons follows the winds that you know in India. It's very difficult, these strategies to recover the instruments, or not?
Yeah, so basically, see, once we release to the ceiling altitude of the balloon, so balloons are carried away by the upper wind conditions. And before the balloon flight, we basically send our small balloons to see the wind profiles. And then accordingly, we send in a favorable directions the main experiment. And then we have a very good receivers like GPS and other sensors are there, which give us the location of the balloon, and then we map them in our own maps, like we have a Google One map, which is the space agency map, or Google map, and we know exact location where this experiment will fall after the cutoff of the balloon. So generally we see the safe place where we want to recover, but this is not the real world. So always sometimes balloons go in a forest and difficult places, but we have a good recovery system. So always not very easy to recover, but good thing is that we recover very safely. That is important.